Hey guys, Paul from Paul's KARTS here. Just wanted to make this quick video. I've been getting a lot of calls lately about, what's best for this carburetor, what's best for that carburetor, what's best for like stock pairing. And it really basically depends on the rules. If you can run a welded intake, then the welded intake tube, these valves, welded intake tube will be your best choice. This one, we can get the CFM requirements for most engines very easily. This is for a Trinity set. This is going for a 72 millimeter engine, and we can get the requirements for that straightforward. This has got 3228. It's got the stainless valves, does come with the retainers and keepers. And springs. In the Trinity set, it comes with the dual coil springs. So this would be your best setup, ideal setup. Something like we run in the Trinity set with the welded intake tube. Now, if you're stock pairing, basically has a bunch of different type of classes. Some just say you need to run a bolt-on intake manifold and you can't have any welding. If you can't have any welding, then you can't run the welded intake tube. But so a welded intake tube will go to like this style carburetor, like a slide carb. This is one of the ones we do. We got the clunk on it. This does have a little filter on it. That way you could see if you get any pollutants in your fuel and stuff like that. If you have stock pairing, you might want to just go with like the standard 399 head. This one here, actually this one's been made for the that budget engine. So that budget engine still has a pretty mean cylinder head on it. That budget Predator we sell, it's only like $1,000 something bucks, but this has a really nice head. As you can see, head quality we put out is really nice. So the 399 head is actually a little bit more ported than this. This one's still done nice, but on the 399 heads we actually take and we'll do it to your spec. This one is basically not really spec'd out. It's basically just ported well. As you can see, the port job, really nice port job, but we don't take the time to get in there and really take it to those finite dimensions to spec it out for your CFM. To really maximize velocity and stuff like that. But it's a really nice head on those budget engines. As you could see, some people were saying that these budget heads, they thought by the description that, it sounded like nothing was really done to them. But as you can tell, they're actually really a nice cylinder head. They got the bronze guides opened up nice. They got the custom pulse KARTS guides in there. They got the non-touching seats. So then, I mean, if you're in the stock pairing class, you might want to stock pairing class. If you're in a Predator 212 class, if you're really running a 212 Predator, you really want to go with the welded chamber. In the 212s, GX200s, 196s, 212 class, the really hardest thing to get in those is the compression ratio. When you get into like a 72 millimeter stroker, this chamber, the way we have this set up, this is going to be able to get you 14:1 compression ratio. This small little welded chamber on a 212 gets you just over 12:1, like 12.1 to 1, 12.2 to 1, depending upon the level of unshrouding and the area around the spark plugs. Now, I've seen a lot of companies or people that put it out and leave this big wedge right here, and it blocks all the spark plugs. So you really got to be conscious of that and take this down in that area, so that way the spark can transition, and the flame travel can transition out of the across the chamber a lot better. And round all this stuff over. This is all smooth when I touch everything. Everything here is smooth. It's all smooth. So in a 212, if you're in a 212 stock appearing, this one actually has the max porting done to it as well. So this is actually assembled. This guy paid for assembly too. And this has the epoxy port, and he actually did the port matching as well. We don't epoxy the manifold, but we'll port match them, take the manifold off, epoxy the head, and then he still needs a gasket in here. I just bolted this on for the video, but yeah, so, but it all lines up. When I run my finger through here, there's no walls, everything is perfectly transitioned. I can't tell where the manifold stops and the head begins. So these are nice. If you got a 212, I would recommend the welded chambers, because these are small chambers. These are like 12cc chambers. Even the 14cc chamber, when you put in the bigger valves and unshroud it, it becomes like 15cc, 16cc with the unshrouding, because you got to unshroud it so that way there's space on the valve. If you don't unshroud it, the valve will be literally in danger of clipping the wall. So you got to unshroud it to get the airflow around the valve. This uses like a Tillotson style carburetor. This isn't for the customer, but I just brought it as an example. You could see it has the little hole, and it has the hole in the manifold, and this would bolt on here like that. We had these in gas and methanol. This is a 27mm cob, and these are like a 28. So these are good. A little bit personal preference on those type of carburetor things. So then you have other things for bolt-on manifolds. You got, so this type of bolt-on manifold will allow you to bolt on a slide style carburetor. I had a customer ask me yesterday. He said he wanted to use a Super BN. He's doing a 76mm build. Got the 3-inch bore, and he was thinking about doing a Super BN style carburetor. Now we use these manifolds on some of our small block heads, some of the ones where we can actually get it on there and weld it on there. But on these, you can see this is kind of too big, you know. So what you would have to do if you wanted to use these two in conjunction with each other to get them on the cylinder head is you'd have to take something that's compatible with the cylinder head, and this way you could still run bolt-on manifold rules. Take this style manifold and weld this manifold to it. Now, even with this, you could see it's very right on the edge. You know, it's barely covering it. So to port match these would be tricky, and you would really have to do a lot of fill welding in this area from like here and taper it up, so that way it would continue this taper all the way down. Probably cut this flange off, weld up that hole, and then just use the hole on this one and put this all the way through. So that would be an option if you wanted to run a BN carb. He was talking about a 32 or a 34 BN carb, being able to bolt that on a small block. Basically, anything you could pretty much think about, you can get done. But you know, if you start getting, say, like a 34mm BN carb, and you're trying to get that down and through. You know, is that the best match? I think a 34 on a small block's a little bit big unless you got the right head set up. We have one of the heads that we use it on, and we got that on the site. But most of the stuff we like is this welded intake tube cylinder head, 28mm carb. If you're on like a 3-inch, depending upon now, we also have the Gorilla Cam, and we have the KARTS 3 cam. Now, a lot of people ask about the camshafts as well. Since we've came out with the Gorilla, before the Gorilla 3-inch bore stuff, we had the Trinity set, which was this exact head with, you know, say a carb like this, and the KARTS 3 camshaft. Now, those were the Trinity set. Now, this chamber will be a little bit small with the KARTS 3 cam to run on a 3-inch bore, because the KARTS 3 cam makes so much cylinder pressure in that setup. The cam manages the cylinder pressure. So if you're blowing out head gaskets and you can't hold on that head gasket, realistically, you could probably look into changing your camshaft out to put the power a little bit higher up in the RPM range. You're probably building too much cylinder pressure. You always build max cylinder pressure at peak torque. Now, if you push peak torque up into the RPM range, you'll get a little bit less peak torque, but you'll make that horsepower a little bit more. So when you have a situation where you can't manage your cylinder pressure and you're blowing out the head gasket, some guys will say, oh, put a thicker head gasket, put your piston down in the hole, you know, unshroud the chamber, you know, anything you could do. These things would lower your compression ratio, and they would try to get the head gasket not to blow by lowering their compression ratio. Blowing out head gaskets is great. If you're blowing your head gasket, that means you're making a lot of power. I wouldn't go the route of lowering compression ratio to make it hold the head gasket. I would change the camshaft to utilize that cylinder pressure at a better point. You could use all that cylinder pressure and just basically you're going to distribute it differently. So instead of building all that cylinder pressure down low and blow the head gasket, you move it a little higher. You still have that same amount of pressure down low, because now your head gasket isn't blowing, but you're also utilizing it at a better point, and you're able to extend the RPM, the band, the curve on the dyno. So I mean, we ended up going to the Gorilla Cam for 3-inch bore stuff. Before we went to the Gorilla Cam, this Trinity set this cylinder head chamber was too high. It was building too much cylinder pressure with the KARTS 3 cam. So we make a Trinity set. If you're using the KARTS 3 cam, we have a Trinity set with the 18cc chamber, the larger of the chambers. There's two starting points in the stock type castings. There's the 14cc chamber and the 18cc chamber. So in a 3-inch bore, if you have a cam that's building a lot of cylinder pressure, you're going to want to step up to the 18cc cylinder head. But now that we have the Gorilla Cam, we're recommending that you use this cylinder head, so you still are able to make all that cylinder pressure, but use the Gorilla Cam with this 14cc. That just goes to show you how much power we're able to make. Power that wouldn't be able to be held before. You would never try a 3-inch stroker with a 14cc head on most cams. It would just blow the head gasket out. So when you get into the Gorilla Cam and this setup, you're just making tons and tons of power. Now the 3-inch stuff, I would really recommend max porting and a 30mm carb. Now we have custom 30mm carbs. Normally the slide type carburetors like this, they usually go from 24 to 28. They're all the same size here. These all match up here from 24 to 28. Once you normally step up to 30 millimeter, this usually gets bigger on the carb. Now we have special ordered 30 millimeter carbs that are these bored out to 30 millimeter, and that still work with these bolt-on manifolds, or even the welded intake tube we use. Now this is the same size. We ordered this tube custom extruded, so it's the same size as the carbs. That way you can go with like a clamp-on carb connector. I'll grab one and show you what I'm talking about. We have these clamp-on style carb connectors, which just basically clamps this on here, allows you to clamp on to the intake manifold into the carburetor. So that's how you would attach the slide style carburetor. Now, if you have the 30 millimeter carb, most of them are bigger than this size here, which is the standard size. We do have it, like I said, that mounts up to this. So I would recommend, if you're a 3-inch stroker, max poured in, and run a 30 millimeter carb. We ordered tubing, custom extruded. That's the size up from this normal size. So once you get to a 30, 32, 34, they're using the bigger size. Then 36 and 38 are a next step up. So we have the custom extruded tubing that we can weld on if you wanted to run either the normal 30, which is, we have the board 30s that fit this. But if you have a normal 30 that won't mount up to your normal manifold, we have the 30 millimeter style tube, so that way you can bolt the 30, the 32, the 34 up to one of these heads. Now 34, a little bit carried away on some of these. It really depends on your engine build and if you can use that amount of air. Now, if you have an engine that's just meant to run, if you're not really riding off road, if you're just holding the throttle and you want to make max power, you definitely don't want any type of restrictions in the system. Max power is made when you really get that airflow lined up with the engine's needs. And that's achieved on the 3-inch bores with the 31, 32 millimeter carb would be ideal. So, you know, a 30 would give you more torque. So when you undersize the carburetor, what you actually do is put the carburetor into like a mode where it's got all the fuel demand that it needs. The air requests the fuel from the carburetor. So when you have an undersized carb, that's why it seems like they're very responsive, because the fuel demand is instantaneous. The carburetor has plenty of vacuum in the intake port to suck that fuel out. So you'll see like a stock carburetor, like a stock appearing carburetor, just like a standard stock carb, those engines, you know, even on gas, they can rev up real fast because the demand is right there. There's so much velocity at that carburetor because the air is so restricted down that it drops that pressure so low in behind the fuel that it allows it to suck up very easy. When it sucks up very easy, it's able to atomize that fuel better because you can use a smaller jet and get more fuel through a smaller jet. The bigger you go with the jet, the bigger the droplet's gonna be. So you actually want a very fine droplet. That's why when you go too much CFM, when you get too much CFM, like if you don't do the math and you just make something oversized, the carb will still work, everything will still work, but it'll be down on power because you won't have the speed in the port. The speed in the port, especially on a carbureted engine, draws the fuel out of the carburetor. So if you don't have that port speed, you don't have good fuel atomization. You don't have good fuel atomization, you have to put in bigger jets. You put in bigger jets and you end up with bigger droplets. So being able to build it right to its needs and nothing more, because it doesn't, its engine's like a syringe. Once it's full, you can't get anything in over that. Now someone's going to say, well, you can operate over 100% volumetric efficiency. And the equations that are done these days, there was equations that I had started with way back when, maybe 4 years ago, when I made some videos and I dealt with 100% volumetric efficiency. But since we've been flowing these things and since we've been dynoing, we're actually operating at 130, 145% volumetric efficiency. So with those type of numbers, that's the equation that we use now. So we operate in a very efficient form, building by the math. So, when it comes down to dialing in all the carburetors and getting your fuel right and getting the velocity as high as possible, that's why you just really got to focus on what you're doing. Make the stuff real nice, how we make it, and you make tons of power that way. It's pretty straightforward to me. Again, I feel like I've done this for a while, and it's what we love to do, or what I love to do. So I'm pretty good at it because it's what I do. But when you get into like a gray area and you're not sure what to do, if you're kind of questioning it, you'd rather be a little bit on the small side than on the big side. You would never want to go and take and put a 32 millimeter carb on a 212. Goes without saying. 34 millimeter carb on a 212. Goes without saying. So there is that point. In your head that there's that point where it's too much. People will, say, well, this flows that much. And I heard some guy stating that he flowed one of my cylinder heads, and he says, it only flowed this much. And when I asked him, well, first of all, I don't think the guy ever bought one of my cylinder heads, to tell you the truth. I think he was just trying to cause trouble for me, which is fine, But when I said to him, okay, well, what size engine was that built for? He never responded, And that's just the thing. They think they know the answer, or they think more is better, but they don't really think, like a chess player, any steps forward. And when you get something like that, I try not to really think too much into it, and I just keep moving forward. But I hear people, or they'll say, this cylinder head flows this much, and right off the bat, I'm just thinking, that's just way too much cylinder head. They were saying there was like a Bellman head that flowed 275 CFM. It's like, come on now. It's like, that's just way too much CFM. This is a carbureted engine. There's no way you're going to have a fuel signal. So everybody knows there is that point where it becomes too much carburetor. And that's why knowing the point to build it to is the most important part. There is the point. If I said, I'm going to put a 40 millimeter on this small block, you would say that's too much carburetor. So there is definitely a point of too much. And that's what I cannot emphasize enough. When we build these engines, and that's why you could see this. So this engine here is built for the 212. You could see how this port is smaller. It's just a smaller port. When this is built for a 240, and you could see how this is, all the way through. It's just a bigger port. So, and then when you go into like 3-inch stuff, you could do the 30 millimeter carb instead of 28, and you run the max porting, and you open up that side of the port that much more. So, I mean, you can get all of what you need out of a cast head. Believe me when I tell you that. All of what you need out of the cast head. The chamber size can be customized. The ports can be customized. When you build it and customize it to your engine, it's gonna fit better. It's like When you buy, you could go out and buy the nicest shirt in the world, and if it's like a 7X, it's not going to fit you. Just because the shirt's nice, you know, it doesn't wear well. You know, if you got a head, or if you bought a shirt and then brought it to a tailor, had that beautiful, nice shirt tailored to you, when you wear that shirt, you're going to look amazing. These heads are tailor-made by hand. You can see my hands. Hard-working hands. All day with my hands. Big meat hogs. You know, these hard-working. You know, this is man-made, not just printed and not designed by somebody that just is connecting. Okay, we need to connect this valve to this port, so just draw it up in CAD. Boom, it connects. All right, it connects. Print it. You know, that's not how you make power. If it was, then, you know, you wouldn't have to change anything in any of the ports. You know, it's just, that's how they made it. You just take their word for it. When, you know, they don't tell you what it's made for, or, you know, they can give you a flow number, but what's the point of a flow number if you yourself don't know how to do the math to figure out if it fits your head or if it fits your build? And is the chamber the right size? You know, all of these things add together into the perfect recipe for making power. So, that being said, if you guys have stayed to the end of this video, I really appreciate it. Please like and subscribe if you haven't already. I could use some likes on videos. We are working to get the build line down. I've already drilled it down to about a month now. We were at 3.5 months out. I've been working Saturdays, Sundays, nights, everything. I did take Christmas vacation off, and that's because I was going so hard. You could tell I wasn't putting out videos. I was literally just trying to grind and get the work done. This is 3 intense heads that I made this weekend. This is a lot of work to get done on a weekend. And on top of this, dealing with the orders and managing a company, it's very intensive. Just emails alone are hours, and I take the time. I've been talking to customers. So I appreciate the support, guys. I love you guys. Check out the products. You can check this stuff out at paulskarts.com. That's paulskarts with a K.com, website paulskarts.com. You can get in touch with me. Best way, actually, you can go through the website. There's a little button that says Contact Us. That's through site contact. That's the Contact Us button. Best way, that actually sends us an email. So the best way is actually to just directly email us. You can email me at paulskarts@gmail.com, paulskarts@gmail.com, or you can text or call 781-492-7358. We're coming into the new year here, guys, 2022. I wish you guys all a happy, safe, healthy new year. I'm Paul. This is Paul's Karts, and until next time, guys, have a nice day.